to the Curious Calculator. In today's episode, we're going to be going over the probability of independent and dependent events. And so I'm going to first be going over independent events and give a little example here with this four-sided die. And then after that, I want to go into dependent events, and then I'll also be giving an example with that one. So let's get started here. Let's look at independent events. Independent events are events that do not affect each other. And the probability of independent events is the probability of the first event multiplied by the probability of the second event. And in symbolized form, we have that the probability of A and B equals the probability of A times the probability of B. And so let's note that if two events are independent, then they must have this right here. This must be true, that the probability of A and B is equal to the probability of A times the probability of B. All right, so let's go into this example here with the four-sided die. And let's see, the first thing that we want to do here is draw out a sample space. And for this example, what I'm going to be doing is we're going to imagine that we roll this die 2 times. And so I'll write that right here. We're rolling 2 times. And so if we do that, then what we want to do is first draw out a sample space of all the possible outcomes that we might have after rolling this four-sided die 2 times. And so I'm going to do that right here. So let's see here. We can get a 1 and a 1. We can get a 1 and a 2, 1 and a 3, 1 and a 4. And then we could get a 2 and a 1, 2 and 2, 2 and 3, 2 and 4, 3 and 1, 3 and 2. Make that look like a, well, make that look like a 2. 3 and 3, 3 and 4. And then we can have 4 and 1, 4 and 2, 4 and 3, and 4 and 4. Okay, so this right here will be our sample space. So these are all the possible outcomes that might happen if we roll this four-sided die 2 times. And we can notice here that the total number of outcomes is, so number of outcomes, or I'll say number of possible outcomes, which, let's keep in mind, is equal to the size of our sample space, is equal to 16. Because we have 4 times 4, or you could count it out. But there's another way to also see what the size of our sample space will be, which is we can think of this like so. Let's say that for each, let's see, for each outcome, or actually I'm going to say for each of the 4 outcomes, each of the 4 outcomes from our first roll, there are 4 possible outcomes for our second roll. And so I'll read this again. So for each of the 4 outcomes from our first roll, there are 4 possible outcomes for our second roll. And so that means that we would need to multiply 4 by 4 to get our sample the sample space size of 16. So I'll just write that right here, that 4 times 4 equals 16, which matches what we got here. All right, so now we have our sample space, we have the possible outcomes listed. So let's get into calculating the probability of 2 events. Well, let's choose what two events we want to look at. So what I'm going to choose is I'm going to say, what is the probability that we roll a 2 first and an odd number second? So my first event will be the rolling of a 2 first, and the second event will be rolling an odd number second. And so let's calculate this. Let's do this first by calculating it using the probability of A and B. So what we're going to do here is we're going to look at the sample space here and try to find where we have a 2 first and an odd number second. Well, looking here, we can notice that that is right here, 2 first, odd number second, and also right here. So that's where we have A and B. And so we can calculate the probability of A and B by doing, so I'm going to write this right here. I'm going to say P of A and B equals, well, we have two outcomes here. And so let's see, 2, and then out of our sample space size of 16. So that equals 1/8, which equals 0.125, which is approximately a 12% chance. Okay, so that's finding the probability using this left side of the equation, doing the probability of A and B. But now let's do it using the right side of the equation, the probability of A times the probability of B. And let's ensure that these two do in fact match, because if they're independent events, then these two must match. Okay, so the second way, let's do the probability of A, and the probability of A, which is rolling a 2 first, will be, well, let's see here. In our table here where we roll a 2 first, we have 1, 2, 3, 4 outcomes where we roll a 2 first. And so that's going to be 4 out of 16. So 4 out of 16, which equals 1/4. And then the probability of B, which is that we roll an odd number second, will be, well, we got to look at all the outcomes where an odd number is rolled second. And so we have 1 here, 2, 3, 4, 5, 6, 7, and 8 here. So that's going to be 8 out of 16, which we can simplify to 1/2. And so that means that the probability of A times the probability of B, so PA times probability of B equals 1/4 times 1/2, which equals 1/8. And again, that's approximately 0.125. Awesome. So we see here that our probabilities match. They're both 0.125. And therefore, we know that these two events are in fact independent. All right, sweet. So that's going to wrap up the independent events example. Let's now move on to dependent events. All right, dependent events. So dependent events are events that affect or that do affect each other. And so the probability of dependent events is the probability of the first event multiplied by the probability of the second event given the first event occurred. And so in symbolized form, this is the probability of A and B equals the probability of A times the probability of B given A. And this right here, where we find the probability of B given A, would be known as conditional probability. All right. So now let's dive into an example with this one. I'm going to do, let's say we imagine we have a bag of 4 marbles. So we have a bag of 4 marbles, and in this bag, let's say I have, let's say 1 blue, 1 yellow, 1 orange, and 1 red marble. Okay, and what I'm going to do is I'm going to pull 2 marbles out. So I'm going to draw 2 marbles, but after I draw the first marble, I am not going to put it back into the bag. So there's no replacement here. And I'm going to write that, I'm going to say, let's see, drawing 2 marbles without replacing the first, or replacing any marble. All right. And let's see here. So let's begin by first drawing out our sample space of all the possible outcomes. And so let's see. I'm going to do that. I'll do that right here. So let's go through this. We could do a blue first, and then we could do yellow, a blue and orange, a blue and red. And notice here that I don't have blue and blue because after I draw out that blue, I'm not putting it back into the bag. So there's no possible way that I could get a blue and a blue if I already took that blue out. All right, so now let's go to the next one here. We could do yellow and blue, yellow and orange, yellow and red. We could do orange and blue, orange and yellow, orange and red. And we could do red and blue, red and yellow, red and orange. So this is our sample space here, and let's notice that we have 12 possible outcomes. So 12 possible outcomes. Draw a line here to separate that. All right, so with 12 possible outcomes, and like the previous one, I also wanted to point out another way to see how many possible outcomes we have. So we can think of it like this. We could say that for each of the 4 outcomes from the first draw, there are 3 possible outcomes for the second draw. And so we can multiply the 4 times 3 here and get that the total number of possible outcomes would be 12. All right, and I'll just read that one more time. So for each of the 4 outcomes from the first draw, there are 3 possible outcomes for the second draw. All right, so now let's choose 2 events here, and then let's go ahead and calculate the probability of those occurring. So I'm going to try and zoom out a little bit here. Oh, there we go. Okay. All right, so let's see here. I'm going to choose event 1. I want to say blue first. Oops. Okay, so blue first. And let's see here. Let's do blue first and orange second. Orange second. So those are going to be my 2 events that I want to calculate the probability of. So let's go ahead and first do this by using the left side of the equation here, finding the probability of A and B. So looking at our sample space here, we want to find where we have blue first and orange second. And that is going to be right here. and there's only going to be one possible outcome where we have that, and there are 12 possible outcomes. So we can say that the probability of A and B equals 1/12. And that approximately equals 0.08, or an 8% chance. All right, so we did that. Now let's go ahead and try calculating the probability using the right side of the equation here. So probability of A, well, that's going to be the probability of drawing a blue marble first. So let's look over here. Let's see, we have 1, 2, 3 outcomes where we draw a blue marble first, and that's going to be out of 12 possible outcomes. So that would be 3 out of 12, which is equal to 1/4. All right, so now let's try and calculate the probability of B given A. So given that we actually drew a blue marble first, what is the probability that we will draw an orange marble second? Now, I'm going to give two different approaches to finding this. The first one is that we can look at our sample space here and just look at this first column here where we're drawing a blue marble first. And we can see that, well, out of this column where we draw a blue marble first, we have one outcome where we draw an orange marble second. And so that means that given we drew a blue marble first, there's only there's going to be one possible outcome where we draw an orange marble second. So out of the 3 outcomes where we draw a blue one first, there's one outcome where we draw an orange one second. So that will be 1 out of 3. The second way to calculate this probability is say, well, if we draw a blue marble first and we don't replace it, then that means that there are now 3 marbles in the bag, and out of those 3 marbles, one of them is orange, so there will be a 1/3 chance of drawing an orange marble on the second draw. So that would be the second way of finding that conditional probability. All right, so let's go ahead and multiply these together. So P of A times P of B given A equals 1/4 times 1/3, which equals 1/12, which is what we got above. And so therefore they match, and we know that these events are dependent events. Awesome. So that is going to wrap up for this video today. I would just like to end with one fun philosophy fact, and that is going to be that, well, did you know that the philosopher David Hume argued against cause and effect? What he's really saying is that we don't actually have any evidence that cause and effect truly exist. All we ever see is, say, an event A happening and an event B happening, and because we see them happening consecutively, we assume that the first one caused the second. For example, if you see one ball hit another ball and that other ball start moving, we might say, well, it is the first ball that caused the movement in the second ball. But he argues that we don't actually see that causal connection. All we really see is the event A happening and then the event B happening.